Ideas. We'll be discussing the NCERT questions that are there in the index, the questions that are given as examples, and also the questions that are there at the back of your chapter as NCERT exercises. So for the topic, that is light reflection by spherical mirrors, the equations that we will be using is F is equal to radius of curvature divided by 2, 1 by the mirror formula, 1 by V plus 1 by U is equal to 1 by F, and magnification, that is the height of the image by height of the object, or minus V by U, which is image distance by object distance. We'll also will have to focus on the Cartesian sign convention, that which we have already discussed. Hope you remember this graph. The first example, the convex mirror is used for rear view on an automobile, has a radius of curvature 3 meter. If a bus is located at 5 meter from this mirror, find the position, nature, and size of the image. So here we have a convex mirror of the rear view mirror of the automobile. So the approach that the first step or approach to this is understanding the question. So draw your rough column. Draw a very rough sketch, which the invigilators will not value. After drawing the rough sketch, you may just cross it out. On your right hand side, you draw your convex mirror and you draw your principal axis. On the principal axis, you will have the pole and the focus and the radius of curvature towards the right hand side of the convex mirror. And here it is given that the rear view mirror of a bus is 5 meter away from the convex mirror. So, and now you wanted what is being asked in the question is, if the bus is located 5 meter from this mirror, find the position, which means that we want to know the image distance, the nature and size of the image, which is actually the magnification. Well, so the first, while writing the solution, first you have to represent what is given in the question. So what is given here? The radius of curvature is given. Then the object distance is given. So when you write these units, you will have to according to the Cartesian sign convention, you will have to give the positive and the negative sign respectively. So it's a convex mirror, so you have the radius of curvature towards your right hand side, that is why our radius of curvature is positive. The object distance is always, be it convex mirror or concave mirror, the object is always placed at the left hand side of the mirror. So the U is going to be in the negative x-axis, so you will be having a negative sign. The image distance V is not given. The height of the image is also not given. And from the given, we have to find V. So for V, we need to use the mirror formula. For mirror formula, we need F also, right? So how do you find F? The focal length is half of the radius of curvature, which is plus 3 divided by 2, which will be plus 1.50. The plus here shows that the image is formed on the positive x-axis. So the image will be formed behind the mirror and it is formed on the positive x-axis, and that is why it will be having a plus 1.5 plus in the focal length will be plus. Focal length will be positive for a convex mirror. And now, according to the formula, we'll have to cut your formula here. So this is your approach to the question. You found your focal length and next you apply the formula. So in mirror formula will be 1 by V plus 1 by U is equal to 1 by F. Mirror formula, mirror M means more, and so put the plus sign. If it is lens formula, think lens as less. So 1 by V minus U will be 1 by F for lens formula, which will come later. For the mirror formula, it is 1 by V plus mirror and more plus 1 by U is equal to 1 by F. Okay, so substituting the values that you have, you formulate your equation as 1 by V is equal to 1 by focal length minus 1 by U. So substituting the value here, you get 1 upon 1.5 minus 1 by minus 5, which is 1 by V is equal to 6.5 by 7.5. So you take the inverse of it, 7.5 by 6.5 will be plus 1.15. The plus shows that the image is 1.15 meter at the back of the mirror. And now the height of the image is not shown. We have to find out. So magnification, while the height of the object is not given. So we know that the magnification is h prime by h, height of the image by height of the object, which is also minus v by u, image distance by u. So now we have minus v, we have v, we have u. Substituting those values, you get a plus minus of 1.5 by divided by minus of 5. So it becomes plus 0.23. So the positive sign shows that it is it's a virtual and direct image, and also it is the image is here the modulus of the magnification is less than 1. So if m is plus 0.23, so it is less than 1, which means the image is a smaller image and is formed at the back of the mirror. So the concluding statement will be the image is 1.15 meter at the back of the mirror. It is virtual, erect, and smaller in size by a factor of 0.23. So the given statements, this is your approach. Given statements, your method of solving the equation, the method of arriving at the answer, substituting the formula, and your concluding statements. All these steps do carry marks. The next one, example 9.2. Here you have an object 4 centimeter in size, is placed at 25 centimeter in front of a concave mirror of focal length 15 centimeter. At what distance from the mirror should a screen be placed in order to obtain a sharp image? Find the nature and size of the image. So you have the image, you have a concave mirror here, and you have an object which is of given height is 4 centimeter. It is placed at 25 centimeter away from the concave mirror. So u is minus 25, and the focal length is given as minus 15. Why minus? It's again the focal length of the concave mirror will be in front of the mirror. So f is minus 15. We have to find the image distance, which is v, and also the image size h prime. So the approach, what are given in the question, we write first, that is object size, the object distance, the focal length, then the image distance, and image size is what we need to find. According to the formula, mirror formula, 1 by v plus 1 by u is equal to 1 by f. You formulate your 1 by v, substitute the values, you get your v as minus 37.5. The negative sign indicates that your image is formed in front of the mirror and it's a real image. And now the magnification formula is h prime by h, which is height of the image by height of the object, which is necessarily minus v by u. We have the height of the object here. So what you need to find is h prime. So you substitute the values, formulate your equation, which will be cross multiplying. It will be minus vh by u. So you substitute those values there. You get the height, the v value and h, and you get your h prime as minus 6. So minus sign indicates it is going to be a real image. It is formed in front of the mirror, and the image is going to be inverted and enlarged. Why enlarged? If you find the magnification, if you substitute the values, it will come as minus 37.5, which is h, which is minus v, and by u will be minus 25. So it will be minus 1.25. No, it's the m will be minus 1.5. So minus 1.5 means it's the modulus value of magnification is greater than 1. So image is bigger image. So it's an enlarged image. So you write your concluding statement. The screen should be placed at 37.5 centimeter in front of the mirror. Why in front? Minus sign here. And the image is a real image. And also we found that h prime is minus 6, which means what it is for, it is going in the minus y axis. That is why it's an inverted image. So looking at the h prime, whether it is have the image height, whether if it is positive sign means it's a virtual image. If h prime is a negative sign means it's an inverted image. And so it's an inverted image and it's enlarged. As I said, the m value is not given in your textbook, but it will be minus v by u. It will come as minus 1.5. So minus sign in the magnification shows that it is an when the modulus value greater than 1 shows that it's an enlarged image. So write your concluding statement. And now we'll be solving the questions that are there in your NCERT exercises, page number 159. The second question comes from this topic reflection. The image formed by a concave mirror is observed to be virtual, erect, and larger than the object. Where should be the position of the object? We discussed that the concave mirror will give you virtual, erect, and a larger image only and only when the object is placed in between focus and the principal and the pole. So I just put the ray diagram here. This will be a maximum of 1 mark question. In a 1 mark question, you will not have to draw the ray diagram. See, when the object is placed in between, you have the ray, one directed to the pole. So it will trace the I is equal to R. It will be reflected obliquely. The ray that passes through the center of curvature will trace back the same path as the the incident angle will be 0 here in this ray. So you get an enlarged image formed behind the mirror only when the object is placed in between F and P. So if the question has a draw your ray diagram and explain, you will have to draw your ray diagram and explain. So according to your question, you will have to answer. This will be a maximum of 1 mark question. In that case, you will not have to draw your ray diagram. And the next one, no matter how far you stand from a mirror, your image appears erect. The mirror is likely to be, in your textbook, there are 4 options given, either plane, concave, convex, or plane and convex. So you know that 2 mirrors give you erect images. What are the 2 images? 2 mirrors. One is the plane mirror and one is concave mirror. Convex mirror. Concave mirror will give you erect image only when the object is placed in between F and P. So you want, no matter how far you stand. So concave mirror will give you erect only based on where the object is kept. In this case, it doesn't matter where you stand, which means what? It is object distance is object. The placement of object is not is not a matter of matter you're going to consider. So every time, no matter where it is placed, you should get an erect image. Means what? It will be only 2 mirrors will do that. One is plane mirror and one is convex mirror. Then the 7th question, we wish to obtain an erect image of an object using a concave mirror of focal length. Just a focal length. 15 centimeter. What should be the range of distance of the object from the mirror? What is the nature of the image? Is the image larger or smaller than the object? Draw a ray diagram to show the image formation in this case. See, you have a concave mirror and it is given that it is the object is placed, the focal length is 15 centimeter. So you want an erect image. So a concave mirror will give you erect image only when the object is placed in between F and P. So what is the range? P will be 0 as per the Cartesian sign convention. P is considered as 0. So 0 to 15 is your range. You will keep your object in between 0, this P and F, that is 15 centimeter, that you keep in between, anywhere in between F and P, you will get an enlarged and erect image. So this will be, your range will be 0 to 15. P is 0 and the final limit F will be 15. Then what is the nature of the image? The nature of the image is formed, the image is formed behind the mirror. It is, it's an enlarged image and also it is virtual and erect. And draw a ray diagram. And this is your ray diagram. You'll have to draw and study the ray diagrams. The next question, 8th question, that is, name the type of mirror used in the following situations. Headlights of a car. So headlights of a car, what do you want there in the headlight? You want a concentrated or converging beam of light, concentrated so that, at a point, so that you will get those converged rays will enlighten the path that you have to follow. So that is, for you to drive, you wanted to see the road clearly. So you want a very parallel stream of light. So where in that case, the concave, we'll be using concave mirror with bulb placed at the focus, so that when the bulb is placed at the focus only, the concave mirror will be giving you parallel stream of light. You will not have to draw a ray diagram in this case, but I just draw it for the explanation. This will be a 1 mark question. So you will have to only write the reason. So the reason will be concave mirror, Why? You want a parallel stream of light, and the bulb is placed at the focus. And next question, side or rear view mirror of a vehicle. The rear view mirror, what is the purpose there? You wanted to have a wider field of vision, and also you want a reflecting surf, you want an erect image. So what is so which is the mirror that you're going to use? The mirror which will give you the wider field of vision will be convex mirror, and the mirror, and you need the image to be erect, so that will be these erect and wider field of vision can be given only by convex mirror. You can use a plane mirror, but plane mirror will not give you a wider field of vision. You will get only an erect image there. And now then the solar furnace. Solar furnace, the concave mirror is used because the sun is at infinity. So the parallel beams from the sun will converge at the focus, and at the focus you keep the coil. So the coil will get heated up, and that heat is used to charge the furnace. So at that point, the light will get concentrated and the heat will be generated, because energy, it will follow the law of thermodynamics. Okay, the energy light ray, the energy can neither be created nor be destroyed, but will only be converted from one form to the another. The light ray is converted to heat energy, and it will be heating up the coil, and that coil, with that, when the coil gets heated, your furnace is getting heated. And this is not your question, but I just added it for your reference. These are called in the cold countries, when the temperature drops down and we want heating in the room. People were using heaters, but the problem with the heaters is the heaters will get heated up so much and it may catch fire. So fire was a very common incidence during winter in the cold countries. So this is something which which many cold countries are using these days, which is actually mirror heaters. That is, they used polished reflectors. They are otherwise called as polished reflectors, and these should be highly polished reflectors. That is, a concave mirror will be very high. It should be a highly polished surface, and it will be reflecting the light. So see, in a concave mirror, when the bulb is placed, uh, uh, you want the light ray will go hit the concave mirror, and it will be when the if the parallel ray falls on a concave mirror, the light will get will converge to the focus, and that focusing, the convergence of the light ray will produce heat, and that heat could be used to uh, uh, used to heat up the room. The good thing about this is you have the instrument at one place, but the focus is, the light ray is going to get converged at the focus, which is in front of the mirror. So what happens is, it is not the heater is not getting heated up. Rather, the concentration or the heat is getting concentrated in outside the heater. So the heater will not get heated up, and the appliance will not get heated up, and it will not catch fire. So the less risk of fire and less risk of heated instrument. And this one is a solar street light. It is that's also not in your question, but I wanted to bring the fact here that the street light uses convex mirror, and the purpose of that is, for the convex street light means you want a scattered light ray throughout. That is, you wanted to have a clear. You wanted to have the vision of the whole area. So you want a scattered light ray. So whenever you want a scattered light ray, you use a concave. You use a convex mirror.